JAM past question 2001. Question number 11. A ray of light strikes a plane mirror at an angle of incidence of 35 degrees. If the mirror is rotated through 10 degrees, through what angle is the reflected ray rotated? Okay. Today's question targets to know your idea of rotation of plane mirror. Rotation of plane mirror. Okay. To solve this, there is a simple formula for this. There is a simple formula. But after that, I'll be teaching you how the formula was gotten. I'm not in support of students cramming formulas without knowing the basis or the foundation that led to the formula. Okay, but I will tell you the formula. Whichever means that is better for you, you can go on with it. Okay. Solution. Anytime you are giving question on plane mirror rotation, that angle of rotation, go back to your question, get that angle of rotation. Notice the incidence angle I is 35 degrees. That's our incidence angle, angle of incidence. While the angle of rotation X, let me call it theta, 10 degrees is the angle of rotation. Then they're asking us, through what angle is the reflected ray rotated? The question is just simple. In the first light incidence, it will have angle of reflection. So when the mirror is being rotated, the reflected ray will shift from its initial position to a new position. With time, I will explain better. Then let me just put R. What is the angle between the two reflected rays? That's what the question is demanding. With time, I'll show it with a diagram. Then the formula there says, to get that angle in between R1 and R2, that angle is 2 times angle of rotation. Whatever thing your angle of rotation is times it by 2. Our angle of rotation is 10. Therefore, the answer is 20 degrees. So the answer to this question is 20 degrees. But let's do it better with diagram. Let's use geometry so you can understand what the question demands. To show what I was saying, we have to use diagrams or lines to show it better. Okay, let's start with the plane mirror itself. These are plane mirror. This is the third suffix. Third, meaning that we are not seeing from here. Then the top part is a reflector. Reflector. Then every plane mirror must have a straight line at angle 90 degrees to it. That will be our normal. This is our normal. Our normal. I want to prove to you what we said earlier, that the angle between the two reflected rays is 2 times theta. That's the angle of rotation. And an angle of rotation in the equation X, 10. 2 times 10. Which will give us 20 degrees. Let's prove it using our construction lines. Recall, there is light source. Light source. And one of the rays coming from that light source will strike the mirror at angle of 35 degrees. Angle of 35 degrees. Then the second law of reflection says the angle of incidence is equal to the angle of reflection. Recall, a plane mirror permits reflection. So the incidence ray indicate the direction, will bounce back, will be sent back. So these are incidence ray. Why this is reflected ray. And it will, the angle, when we come to the angle, no more the line. The lines are the rays. Then coming to the angle, also have 35 degrees. Okay, this will happen at the first experiment. In the first experiment, we have this. Incidence ray, normal, reflected ray. The same angles between the incidence ray and normal and reflected ray. Okay, so the question now says, if I now rotate my plane mirror, what will happen? I'll use another form of line, zigzag line, to show the second experiment. These are first experiment. We've seen what happens. Then let's go to second experiment. So this time I will do freehand sketching. Use zigzag. Then I'm now rotating my mirror. This is a plane mirror, but with a new line now. This is my plane mirror. The angle of rotation from the question is 10 degrees. Here will also be 10 degrees. Vertically opposite angles are equal. Then notice, as soon as you rotate the plane mirror, the normal will also rotate. The normal will also shift. I'll have a new normal, because the normal is always targeting 90 degrees. So let me call this one N prime. The normal is now at 90 degrees with this new plane. So this is my new normal. 90 degrees. Yeah. Okay. So I have new normal. And notice, I shifted this plane mirror from this point. The normal also shifted from that point. Therefore, they will maintain the same angle. It will also be 10 degrees. As soon as the mirror is shifting, the normal is also shifting from its initial normal. The new normal shifts from the initial normal the same way the mirror shifts from its initial points. So the angle is always the same. The angle of rotation from the new plane of the mirror to the initial plane is 10. The angle of rotation from the new normal to the initial normal is also what? 10. Then recall, the light source did not rotate. The light source was maintained all through. I'll be having new angle of incidence. Your angle of incidence is always measured from the normal. All measurements are taken from the normal. Take note of that. You can notice here, our initial angle of incidence was measured from normal. Our initial angle of reflection was also measured from the normal. So we now have new normal. I'll be having new angle of incidence from the new normal. So I will do 10 plus 35. So my new angle of incidence is 45 degrees. In the same way, I'll also have new angle of reflection. This ray will bounce again. This time, for the second experiment, I'll also be having zigzag line here again to show the new reflected ray. This is the new one. This is the initial one. Let me call it R1 and call this one R2. Therefore, measure from the normal again. Recall, I have 45 degrees. Provided it's a flat mirror, I also have 45 degrees again. From here to there. 45 degrees again, because for a plane mirror, the angle of incidence must be equal to the angle of reflection. Okay. Then, what the question is now demanding is the angle between R1 and R2. That's what the question is demanding. The initial reflected ray shifted to a new position, which is the final reflected ray. What's the angle between R2 and R1? That's what the question is demanding. Then we'll do simple arithmetics. Then notice, let me call this X, that angle X. Then notice something. This S is smaller than 45 degrees. Notice the angle X is smaller than 45 degrees. Then also notice something. If I get this angle, notice that angle. The angle between the new normal and the initial reflected ray. When I get that angle and subtract it from 45, I'll be getting my X. So let me call that part Y, capital Y. Then let me call my 45 Z. Then notice, to get X, I'll be having Z minus Y. Then let's find X. Z is what? 45 minus. Then notice Y. We'll play smart. Yeah. Don't forget, there is angle here. 35 degrees. The initial angle of reflection is 35. And that 35 contains Y and also contains 10. Are you seeing? Addition of 10 and Y is 35. 10 plus Y is 35. Then common sense will now tell you that Y is equal to 35 minus 10. Y will now be 35 minus 10 to get what we drop here. And that is 25. Therefore, Y is 25. 25. Finally, S is equal to 20 degrees. S becomes equal to 20 degrees. That means the final reflected ray shifted away from the initial reflected ray at angle of X, which is 20 degrees. So the shifting that happened from R1 to R2 happened at angle of 20 degrees. That's what we solved since with our formula. Okay, thank you. Just take time to observe the geometry. You can also do it on your own using two colored pens to make a better difference. But don't forget, this 10 degree will always fall in between 35 because 35 degrees is greater than 10 degrees. Be conscious of your angular difference. The 10 is smaller than 35. It should not exceed 35. So you can do that on your own to see how good you are in showing that formula using geometry or construction lines. Thank you.